Hello Calculus 2 students, here is another exam problem set. Here's the first problem. Use Riemann sum and Riemann integral to calculate this limit. How do you know this is a Riemann sum? Well, we have k over n and we have k over n squared. So you can rewrite this integral like this. Like that. Now we have k over n here and k over n there. Let's take one more step. K over n, k over n. So please note that the original expression and this one is the same. Now we have k over n, and that's going to go over 1 over n, 2 over n, 3 over n, all the way up to n over n. So they go to the right-hand side endpoint of these subintervals. And then this is the width of the rectangle. And function values, these becoming height. So we have Riemann sum. So we have integral and the summation, k is going from 1 through n. So that's going to be a integral from 0 to 1. Most of the time it's going to be 0 to 1, but if this is going to 2n or 3n or 4n, then you're going to go to 0 to 2, 0 to 3, 0 to 4, kind of like that. So k over n is going to x, and then 1 over n is dx. And all we have to do is calculate this integral. Make sense? The key is to get k over n. We have k over n over here, that's fine. We have k over n squared, so we need k over n. Move one n to the other side, and we have 1 over n, and that becomes dx. K over n becomes x. And then as for calculating this integral, this is going to be integration by parts. Here you go. We got the integral, and then we use the integration by parts. Here you can put u as log of x, because that has the strongest tendency for u. V prime is x, so u prime is 1 over x, or x to the negative first power. V is 1/2 x squared. You see, u goes to u prime, v prime goes back to u, and then if you put everything into integration by parts formula, we have u times v, so that's what we have here, u times v, minus u prime v, so we have this. As for this part, we can simplify into 1/2 x squared log of x, and as for that part, we can calculate the antiderivative. Let's see, 1 over x and then x squared, so we have just 1/2 x to the first power, and taking the antiderivative, you have x to the second power. So this is just integration by parts. Now we want definite integral, so use this integration by parts to get this indefinite integral right here, and then plug in the top 1 and plug in the bottom 0, subtract one from the other, we get the integral computation. Okay, so much for the first problem. How about the next problem? We need k over n. We have k over n over here in the numerator, insufficient, so you can artificially create one. So you can rewrite this thing as so here I need k over n, and that'll do it. You see, this n times this 1 over n multiplying the denominator, they'll cancel each other out. So that's a good decomposition. And we have k over n here, k over n there. So we are in business. K over n becomes x, and then limit and summation is integral. 1 over n is dx. So let's do this. This part is the integral. Integral 0, 1. That part is this. And then now 1 over n is dx. And then the middle part, log of x over x. That's the computation. K over n is becoming x. Maybe I have to increase the font. Okay. K over n is x. K over n is x. So we got the integral. Now, how do you calculate the integral? Well, please note that this is a integration by substitution. If you use u as log of x, then du is 1 over x dx. And we have 1 over x dx over here. You see? So this whole thing is actually like this. You can write like this. So basically, this 1 over x dx is becoming du, and then log of x is u. Or, u is log of x, just du is d of log of x, so you can rewrite like this. D log of x. And then you can calculate the antiderivative with respect to log of x, so it's just first power function. So we go over to second power function. Of course, if you're uncomfortable with this, and then you can use the integration by substitution. That I'm going to leave to everybody. And let's just go over to the shortcut method. So d of log of x. So taking the antiderivative, log of x squared over 2. That's the antiderivative. Now that one goes inside, and then plugging in x equals to 0, x equals to 1, subtract one from the other using the fundamental theorem of calculus. What do you get? You get log of 0 popping up. Log of 0 is going to negative infinity, and that's 1 squared, so that thing is positive infinity. So everything boils down to just negative infinity. So that's the answer. Answer is negative infinity. Okay, we went through 2 Riemann sum problem. One convergent, one is going to negative infinity. And as for the other problems, we can do those in separate videos. Let's stop here.